Okay, today we're going to talk a little bit about fractions in this section. It's important that you know how to deal with fractions. It's actually one of the most important topics in algebra, and we're going to work this section by doing a whole lot of problems. So if you can do these, you'll be in good shape as far as fractions go. We'll start out with some easy things and we'll get into some more challenging things. So let's just take some examples right out of the gate. First thing we're going to do is learn how to simplify fractions. Here's a fraction, 6 over 12. And that fraction basically means 6 divided by 12. Fractions are just another way of saying divide. So it's really no big mystery. It's 6 divided by 12. There are many different ways to write fractions, and one of the most important things that you're going to have to learn how to do is learn how to reduce these things, or to simplify them into lowest terms. For this example, for instance, what you basically do to simplify a fraction into lowest terms is you try to figure out if there's any number that you can divide into the top and that you can also divide into the bottom to go an even number of times. And then when you do that, you'll get a new fraction, and that fraction will be simplified. And let's just take an example. In this case, I know that I can divide the top by 2. Let's say, what is 6 divided by 2? 6 divided by 2 is 3. What is 12 divided by 2? 12 divided by 2 is 6. So these two fractions are exactly equivalent to one another. 6 over 12 and 3 over 6, they're exactly equivalent. There's no difference. If I try to draw these fractions like on a pie graph, okay, there's 4. Here's 2 more. How many pieces do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's pretend these are all even slices. So here's 6 slices of the pie right here. Okay, and here's 6 more slices. So this fraction is 6 out of the total number of slices, which is 12, and that's the representation of 6 over 12. This other fraction off to the right we can do like this. So there's 1. Here's another line through the pie. That's 1, 2, 3, 4 pieces. I can cut this one. That makes 6 pieces of this pie. Now, if I shade this guy, okay, there's 1 piece, 2 pieces, 3 pieces. Again, it's half the pie. So both of these fractions are equivalent. Now, interestingly, look here. It looks like 6 over 12, 6 pieces over 12 total pieces is about half of this pie. 3 pieces over the 6 total pieces is about half of that pie. So it looks like, if I take, just to prove it, it looks like this also equals a half of a pie, right? So let's try and test that out. What can I divide into 3? Let's take 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So all of these fractions are exactly equivalent to one another. All I've done is divided the top and the bottom by the same number, and then I arrive at an answer that looks different, but it's in fact exactly the same. And so this is kind of like a mini equation. When you simplify fractions, just know that you can divide the top and the bottom. You can do anything you want, actually, to the top and the bottom, multiplication and division wise. You can multiply the top and the bottom by the same number, you can divide the top and the bottom by the same number, and as long as you do it to the top and the bottom, you change the numbers, but the actual fraction itself is the same, which is kind of what is illustrated here. So let's move on. This will become a whole lot more clear exactly what's going on as we do, a whole lot of additional problems, and we're just going to kind of do them kind of rapid fire here and get a whole bunch of problems in. Okay, let's say 15 divided by 20. What can I divide in the top and the bottom that'll go an even number of times? Let me say 5. Okay, 15 divided by 5 goes 3 times. 20 divided by 5 goes 4 times. So these two fractions are equivalent, and they're exactly the same. They're just written differently, and this one is simplified because there is no number that can go into both of these an even number of times. I mean, if you pick 3, 3 goes into 3 once, but 3 doesn't go into 4 an even number of times. There's no number that you can pick to simplify that any further. Okay? Let's pick another. Let's say 24 over 18. Okay? What can go into both of these? 6 can. What goes into 24 divided by 6 is 4, because 6 times 4 is 24. And what goes into 18? This 18 divided by 6, you got to use the same number, is 3. So it looks like 4/3 is the answer to that. So these two fractions are equivalent. And then we'll pick a little bit harder one, 72 by 64. This is kind of tough. You have to play with this one a little bit to figure out what common number will go in there until you realize that 8 goes into both of these an even number of times. So 72 divided by 8 is 9. 64 divided by 8 is 8. So these numbers, these fractions, are exactly equivalent. You just have to spend a few moments to try to figure out what the common number is that you can divide into there, and then the rest is actually pretty easy. And remember, you can multiply and divide the top and the bottom of fractions all the time, as long as you do it to the top and the bottom at the same at the same time. Then the fraction isn't changed. That's the only way we can write that equal sign there. So let's move on from simplification into multiplication. So let's multiply some fractions. Let's say we have 1/2 multiplied by 3/5. Multiplying fractions is easy. It's really, really, really easy, actually. All you need to do is realize that you just have to multiply the top and the bottom number separately, and then you're good to go. Okay? So all you have to do to multiply fractions is multiply the top separately, and that gives you the top number, and multiply the bottom separately, and that gives you the bottom number. It's very, very simple. 1 times 3 is 3. 2 times 5 is 10. That's the answer to the problem, 3/10. You got to ask yourself after every time, is 3/10 simplified? And the answer is yes. There is no number that goes into 3 and that goes into 10 each time an even number of times. There's nothing you can think of to do that. So let's move on and do another. 4/3 times 6/5. Again, multiply the top. 6 times 4, 24. 3 times 5, 15. That is the answer to the problem. However, it's not simplified. You can make this fraction a little bit simpler. What goes into 24 and what goes into 15? And the answer is 3. Okay? Because, and we'll do it with the bottom here first. 3 goes into 15 5 times. 3 times 5 is 15. 3 goes into 24 8 times. So I can pick a number that I can divide in there and give me even numbers out here. So the answer is 8/5. That is the reduced form of the fraction for this problem. And just picking more examples. 5/12 times 18/5. Now I'm going to teach you a couple tricks along the way here. We could multiply 5 times 18. We could get a number over there, and we can multiply 12 times 5, and that's 60, and we'll put that on the bottom, and then we could try to reduce that fraction. And that makes a great amount of sense. Okay, but we need to learn to think about what the fraction's doing here. You notice there's a 5 here. That's common to both of these things. Before we answer the answer to this question, let me just ask you something. 1 times 2 is 2. 2 divided by 2 is 1. So looking at this is just an aside here. I multiply by 2, and then I take the answer and I divide by 2, and I get what I started with. 1 times 2 divided by 2 is 1. I end up where I start. Because, think about it. You're taking a number, you multiply it, and then you divide it by this very same number. So, in fact, the multiplication and division cancel each other. In this case, I'm basically taking 18 times 5 divided by 5, and then I'm multiplying the answer times 1/12 over here. So basically, anytime you have something in the top and something in the bottom that's common, you can simply put a line through it because it doesn't matter. Yes, you can multiply it and you can multiply the bottom, and what would end up happening is they would divide out in the end. When you have common numbers in the top and the bottom, you can divide them out. And again, we could take the answer here. We could go, and when I put a line through here, what I mean implied is that this is a 1. 1 there and a 1 there. So 1 times 18 is 18, 1 times 12 is 12, so we could put 18 over 12 and we could simplify that fraction, and that would give us the right answer. But let's take it a step further and try to simplify it even just a tiny bit more. Here's 18 and 12. again, I can play with these fractions all day long before I actually do the multiplication. Is there a number that goes into 12 an even number of times and that also goes into 18 an even number of times? The answer is yes. The answer is 6. So what I can do is I can strike through 12 and say 12 divided by 6 is 2, and I write a 2 there. And 18 divided by the very same number, 6, is 3. You see, I've done a lot of crossing here. I've simplified this fraction even before I've done the multiplication. I struck out the 5s because they cancel, and then for these two numbers, I pick a number, 6, and I divide in there, and I can simplify this fraction. So what I really have is 1 over 2 times 3 over 1. The answer is 1 times 3 is 3 over 2 times 1 is 2. That is the answer to the problem. And I promise you that if you were to take 5 times 18 and 12 times 5, the original problem, and do it in your calculator and try to simplify it, you will get 3/2, because all we've done is a simplification up front. We've simplified the 5 over 5, which is always 1, and we've simplified the 18 over 12, which is simplified to 3/2, and we multiplied those new simple fractions, and we arrived at the same answer that you would have gotten had you done it the other way. So you'll find that as you do these problems that there's many ways to accomplish the same thing. You'll find that there's many ways to skin a cat, so to speak. Algebra is very forgiving that way, and that's one of the nice things about it, is that if you see a simpler way to do something, as long as it's legal, it's kind of like chess. You've got to know the rules, okay? But once you know the rules, you're all set up to do, all kinds of fun things with it. As long as you know the rules. If you start getting out of the bounds and trying to do things too fast and start skipping steps and not paying attention to the rules, then you get into trouble. All right, let's proceed. Again, multiplication of fractions. 17 over 34 times 3 over 6. Now again, before we actually do this multiplication, try to multiply 34 times 6, something huge. Let's see if we can simplify this, okay? First of all, 3 and 6, that jumps out at me right away. I can simplify this fraction right away by noting that 3 goes into both of these even number of times. So 3 divided by 1 is 1. 3 divided by 3 is 1, and 6 divided by 3 is 2. So this fraction goes down to 1/2 right away. And then the question is there anything else I can do to this fraction? And the answer is yes, because over here I have 17 over 34. It may not be intuitively obvious at first, but 2 times 17 is 34, okay? So 17 goes into 17 one time, and 17 goes into 34 two times. So now I've transformed this whole problem to 1/2 times 1/2. So we multiply the top, we get a 1. We multiply the bottom, 2 times 2 is 4, we get the bottom. 1/4 is the answer. And that's a whole lot easier than taking 6 times 34 and 3 times 17 and then trying to simplify that fraction. If you do it that way, you'll get exactly the same answer, as long as you simplify the problem. Okay, 12 times 5 over 6. Alright, now at first glance, this problem looks difficult because 12 looks somehow different than a fraction. So you're like, well, how do you multiply this? All you need to remember is any whole number, 1, 2, 3, 10, 59, whatever, always is the same thing as 12 divided by 1. So just put it there in your problem. Because think about it, 12 divided by 1 is 12. So that's the definition of a whole number. So now here's my problem. And let me try to simplify this before I go 12 times 5 and 1 times 6. I notice right here that I can simplify 12 and 6, because 6 goes into both of these an even number of times. So 6 goes into 6 one time, 6 goes into 12 two times. So here's my new fraction. 2 times 5 is 10, 1 times 1 is 1, and again, anything over 1 is the top number, so the answer is 10. That's the answer to that problem. So once you get the hang of it, it's really not that terribly difficult. Let's move on and do another. 10 over 21 times 14 equals. Again, notice 14 is simply 14 over 1, so I'll just put it there. And I could do the multiplication, and then I could simplify. And indeed, looking at it, I don't think there really is a quick way to simplify it. Or at least not one that I can notice off the top of my head. Actually, I do see one, but Well, let's go ahead and simplify it. It looks like 7 is common to both of these things. 7 times 2 is 14, 7 times 3 is 21. It didn't jump out at me initially, but that's the case. So 14 divided by 7 is 2. 21 divided by 7 is 3. That makes this thing a whole lot easier. 10 times 2 over here is 20. And 3 times 1 is 3. And I don't know about you, but I can't figure out how to simplify 20 over 3. I can't think of a number that goes into both of them an even number of times. So I'm going to call that the answer. Now, in class, you've learned about improper fractions. This is technically called an improper fraction anytime the top number is bigger than the bottom number. And you'll learn how to convert those and all that stuff later. We'll do a little bit more of that later. But that's the gist of this part of the class, is on how to actually multiply the fractions, and so that's what I'm focusing on right now. We'll talk a little bit more about the mixed numbers, the mixed fractions, which isn't really a big deal. In fact, you'll find out the goal of mine in this class is that algebra isn't a big deal. It's really gotten a bad rap. It's not that hard. It's just a bunch of rules, and we'll get through it. Okay, we've done multiplication. Let's take a look at division. The great thing in algebra is division and multiplication are almost exactly the same thing. You don't have to learn really much new. So let's take one. 3/5 divided by 2/3. Okay? Let me just show you one more way of writing this. Okay? It's the same problem. 3/5 divided by, with a big division bar, 2/3. This is the same problem. Normally, it's something divided by something. In this case, the thing on the top is a fraction, the thing on the bottom is a fraction, but I'm still doing division, so I put a line there. All you need to remember is when you're dividing, this is really cool actually. You write the first number, 3/5. Division always turns into multiplication. It is just related to multiplication that way. So when you're dividing, you just put a multiplication symbol, and then you flip the second fraction to 3/2. And then you do it as you would do a multiplication problem. It's very simple. You turn division into multiplication. You put a multiplication sign, you flip the second fraction around, and then boom, it's a new problem, and we already know how to solve these. So 3 times 3 is 9. 5 times 2 is 10. Boom, that's your answer. No further thinking required. If you're presented with it in this form, which is, again, the same thing, all you'll do is you'll turn it into 3/5, and I like to put my fingers and actually flip him over the bar and make it a multiplication by 3/2, which is exactly what we wrote up there. But you may, in fact you will, see it both ways as we go through the course. Especially, it looks pretty obvious now, but sometimes when we get into the harder expressions, you're going to start to see a lot of different ways that thing's written. So let's just do a few more. 3/4 divided by 6/5. So that equals 3/4 times 5/6. All we do is flip it. This equals 3 times 5 is 15. 6 times 4 is 24. And we see if we can simplify that, and you notice that you can divide both of those by 3. 15 divided by 3 is 5. And 24 divided by 3 is 8. The answer is 5/8. And that's it for that one. And again, it's going to look like we're doing a lot of repetition, but repetition is the secret to doing these things. 2/13 divided by 8/13 equals 2/13 times 13/8. Notice right away, 13s jump out at me. Anytime I have the same thing on the top and the bottom, I can cancel them, put a 1 there if I want. It goes away, because times 13 divided by 13, it goes away. Again, 2 and 8, I can simplify that. 2 goes into 2 one time, 2 goes into 8 4 times. So I can do the multiplication. 1 times 1 is 1. 1 times 4 is 4. Answer is 1/4. Not a big deal.